Okay, algebra kids. So today we're going to learn how to factor polynomials. We're going to learn several different methods for factoring. The one we're going to focus on just today is called factoring by finding the greatest common factor, which is why we abbreviate it GCF, because greatest common factor takes a really long time to say, and ain't nobody got time for that. So what is the greatest common factor? It is the greatest common factor for numbers. Forget about variables, just for numbers. It's the largest number that evenly divides into both numbers. This is not the rule for variables, but we are going to get to variables in just a minute. Just for numbers, the largest number that evenly divides into both numbers. So for example, if I were to give you the numbers 4 and 6. 4 can be divided by what?
2.
What can the number 4 be divided by?
Does my microphone work?
4 and 2, says Brock, it can be divided by 4. It can be divided by 2. 4 divided by 4 divides evenly. 4 divided by 2 divides evenly. There's one more. 1. Okay, 6 was our other number. What can 6 be evenly divided by? 6 can be divided by 3. Good. 2. 6. And 1. So greatest common factor, number 1 has to be a factor that they have in common, meaning both of these numbers can be divided by that. So let's go and see what numbers appear in both lists. So the number 4 can be divided by 4, but 6 can't. Number 4 can be divided by 2, and 6 can, so 2 is a common factor. And the other number that appears in both lists is 1. So 2 is a common factor and 1 is a common factor. But the greatest common factor, or GCF, the common factor that is largest, is 2. So the greatest common factor of 4 and 6 is 2. Okay, let me give you two different numbers. Let's get bigger numbers. How about 36 and 45? So let's start off with 36. 36 can be divided by. Can be divided by 3. 1. Can it be divided by 2? It's even, right? So it can be divided by 2. So it can be divided by 1, 2, 3. Can it be divided by 4? $36 divided by 4, does that come out evenly? I think 36 divided by 4 is 9, right? So 4 works. Can it be divided by 5? No. Can it be divided by 6? Yes. 7? No. 8? No. 9? Yes. Can't be divided by 10, can't be divided by 11. It can be divided by 12. Can also be divided by 18, and it can also be divided by 36. Now you'll notice that we've got, I'm going to make a little adjustment here. This 1, 2, 3 at the beginning, I'm going to put these in order from least to greatest so that I can show you a little trick for getting this list of factors. What I want you to notice is that the first number and the last number, 1 times 36, is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. And of course, 6 squared is 36. So if you've done this correctly, you'll have pairs of factors that can multiply together to get your original number. Let me show you what I mean with 45. Now, of course, when we do 45, the easiest one to start with is 1 can be divided by 45 can be divided by 1, and 1 times 45 is 45. So 1 and 45 are going to be factors. Can it be divided by 2? No, because it's not even. Brock says it can be divided by 3, and he's correct. 3 times what gives me 45? 15. So 15 is going to be another factor. 3 and 15. It can't be divided by any even number. It's not going to be able to be divided by 4, 6, 8, 10, 12, because 45 is an odd number. So none of the evens are going to work. It could be divided by 5. 5 times 9 is 45. So 9 will be another factor. Can it be divided by 6, 7, or 8? No. So let's look at our lists, and we've got some common factors. Both lists have 1. Both lists have 3. Both lists have 9. And that's it. Those are the only numbers they have in common. So 1, 3, and 9 are common factors. They are not the greatest common factor. The greatest common factor, or GCF, is just the one that's biggest. Which one's biggest, kids? 1, 3, or 9? 9. 9's bigger than 1. If you said 1, you are either very funny or in desperate need of help. Now, let's talk about finding the greatest common factor of variables. Believe it or not, finding the greatest common factor of variables is much, much easier than finding the greatest common factor of numbers. Is the exponent common to both variables? Check out how easy this is. Let me give you x to the 4th and x to the 3rd. So x to the 4th is x times x times x times x. X to the 3rd is x times x times x. How many x's do they have in common? The first one has 4 x's. The second one has 3 x's. So they both have, very good, Brock, they both have at least 3 x's. So the GCF here is x to the 3rd. It's literally that easy for variables. So, Pedro, please stop trying to take Brock's thunder. So the variables are much easier to find the GCF of. You just find the variable with the lowest exponent. That's the GCF. So if I asked you for the GCF of x to the 29th and x squared, the GCF would be I get what you're saying, Pedro. It's not 2, it's x squared, but yes, the 2 exponent. X squared would be the GCF. So let's put them together. What if I asked you to find the greatest common factor of 36x to the 4th and 45x cubed? We've already done all the math that we need here. We've already found the greatest common factor of 36 and 45. Greatest common factor of 36 and 45 was 9. We've also already found the greatest common factor of x to the 4th and x third. It was x to the 3rd. There it is. The answer is 9x cubed. So when you're asked to find the greatest common factor of a monomial that has both a constant and a variable in it, you find the greatest common factor of the constants, then you find the greatest common factor of the variables, and then you mush them together, just like peanut butter and hummus. Don't knock it till you try it. You prefer jelly? Jelly and hummus? Fine. God bless the chickpea. I've had a sandwich with just peanut butter on it, but I don't think I've ever had a sandwich with just jelly.
It's called toast.
Well, when I have toast, I usually put butter on it. Like not peanut butter, but just butter.
Do you ever do butter and jelly?
Okay, Mando, what are you confused about? Are you confused about the surge of positive emotions that this is making you have? I was the same way too. You know what? The high, it never goes away. Every time you do polynomials, it's just cloud 9 the whole time. What are you confused about, dear? We do GCF with both numbers and variables. So in the example that I just wrote, the GCF of 72a squared b to the 5th and 27a cubed b cubed, first we're going to find the greatest common factor of 72 and 27. Then we're going to find the greatest common factor of a squared and a cubed. Then we're going to find the greatest common factor of b to the 5th and b cubed. And then those three things that we found multiplied together is the greatest common factor of the entire monomial. And the hardest part is the numbers. The 72 and 27 is the hardest part. So we need to find the GCF of 72 and 27. Then we need to find the GCF of a squared and a cubed. And then we need to find the GCF of b to the 5th and b cubed. We're going to do each piece separately, and then after we have done each piece separately, we're going to mash them together. And when I say mash, I mean multiply. So let's do GCF of 72 and also 27. So we're just going to write out all the multiples. So 72 would be, 1 times 72 is the easiest one. So 1 and 72 are going to be multiples. And 72 is an even number, so 2 will also work. 2 and 36, 2 times 36 is 72. 3 also works. 72 can be divided by 3. 3 and 24. Can it be divided by 4? Yes. 4 and this one's harder. 4 and what's 72 divided by 4? That's right, nobody. 18. Didn't leave myself enough space. 5 won't work. Will 6 work? Yes, it will. 6 times 12. Will 7 or 8 work? 7 won't, but 8 will. 8 times 9. And 10 and 11 won't work. And now we're back up to 12, which we already have on our list. So we know we're done when the numbers start repeating like that. All right, let's do 27. We can do 1 and 27. 27 is an odd number. So 2, 4, 6, 8, those are not going to work. 3 will work. 3 times 9 is 27. What else? Well, 4, 5, 6, 7, 8. None of those. So that's it for 27. 1, 3, 9, and 27. So let's look for the factors that we have in common. They both have a 1. They both have a 3. They both have a 9. They don't both have a 27. So the greatest common factor is going to be 9. Yes.
Oh, you're teaching. When you were not, sometimes a day, I need you, it's not a rush. Your calendar integrated into my day and I can't get it into a separate column.
Okay.
Maybe you can help me work on that, but that is not a rush at all.
Yes, ma'am. No problem. Right. So 9 is the greatest common factor. And it looks like Mr. Pascal already did the variables for us just because those are so simple. A squared and a cubed, you go with the smallest exponent. The smallest exponent there is 2, so that'd be a squared. And then same thing for our b's, b to the 5th and b cubed. The greatest common factor is b cubed, smallest exponent. So we now have 9, a squared, and b cubed. So 9a squared b cubed is the greatest common factor. Now what this tells us is our 2 original terms, our 2 original monomials, 72a squared b to the 5th and 27a cubed b cubed, both of those could be divided by 9a squared b cubed, which is important to us because we are about to do that in order to factor. In order to do some factoring, we're going to have to find the greatest common factor and then divide it.
Is that where it's the 2 parentheses?
It will be 2 parentheses eventually, but today it's just going to be 1 parenthesis. This is our first day of factoring, so we're easing ourselves into it.
Well, that's exciting.
And I'm going to ease you into it by doing something that we already found the greatest common factor of. 36x to the 4th and 45x cubed. Oh, sorry, question. You have a question? I'm waiting for the question. Waiting on the question to come up in the chat. Been waiting. Can we multiply the smallest number until it multiplies into the biggest number? Can you multiply the smallest number until it multiplies into the biggest number? I mean, that works sometimes. Like if our numbers were 6 and 12, then you could, the smaller number would multiply to give you the larger number, but that's not always true. Like 36 and 45, 36, no matter what you multiply it by, is not going to give you 45 and for the whole number. I guess you could do 36 times like 1.25 or something. I don't recommend that. So the answer to your question, if I'm understanding the way you're asking it, is no. That works sometimes, but not all the time. You want the biggest number that you can divide both things by. So like if I was really doing 72 and 27 myself, I probably wouldn't write down 1 and 3 to start off with, because the greatest common factor could be 1, but is rarely 1. I'd probably start with the biggest thing I could think of that you could divide 27 by. The biggest thing you can divide 27 by is 27. And then I would ask myself, can I divide 72 by 27? And the answer is no. What's the next biggest thing I can divide 27 by? That's 9. Can I also divide 72 by 9? Yes, I can. 9 is the greatest common factor. So when you are factoring an entire problem, the first thing you start off with is finding the greatest common factor. Now, the reason we did 36x to the 4th and 45x cubed is because we already figured out the greatest common factor to that one. It was 9x cubed. We figured that out earlier in our notes, 9x cubed. So the greatest common factor is 9x cubed. Now, here's how factoring works. Factoring is sort of like doing the distributive property in reverse. The distributive property is when you have something outside parentheses, like a 3 and then an x plus 4, and you distribute that to get like 3x plus 12. Factoring means I want to work backwards. I want to have something outside the parentheses and then something inside the parentheses. What are the two things I multiply together that give me 36x to the 4th, 45x cubed? And finding the greatest common factor is a really important part of this, because the greatest common factor is the piece that goes outside of the parentheses. My greatest common factor was 9x cubed, so 9x cubed is going to be the thing outside the parentheses. And now the question that I have to ask myself is, okay, if 9x cubed is outside the parentheses, what goes inside the parentheses? The first thing that I ask myself is, how many things should be in the parentheses? I'm not concerned with what they are yet. I'm concerned with how many there will be. Now, the problem had 2 terms in it. 36x to the 4th is 1 term. 45x cubed is 1 term. So if there's 2 terms in the problem, there will also be 2 terms in the parentheses. We'll separate those with a plus sign, because there was a plus sign in the problem. Now think about doing this problem using the distributive property. If I was doing the distributive property, the first thing that I would do in the distributive property is 9x cubed times whatever was here in this spot. 9x cubed times this thing is the first part of the distributive property. And I already know that when I do 9x cubed times something, I should get this 36x to the 4th. So 9x cubed multiplied by what gives me 36x to the 4th. Now you can sit there and think to yourself, like try to do it mentally. Okay, 9 times 1 doesn't work. 9 times 2 is 18. 9 times 3 is 27. Oh, 9 times 4. 9 times 4 is 36, so it must be 4. Right? But there's an easier way to do it, a faster way to do it, and it goes back to why I taught you polynomial division. The way that you can figure out what should go in there is you take your polynomial that you should get, 36x to the 4th, and divide it by the greatest common factor, 9x cubed. So 36 divided by 9 is 4. What's x to the 4th divided by x cubed? I have 4 on top and 3 on bottom. 3 of the ones on top will cancel with the 3 on the bottom, and you are exactly right, Shelby. It's x to the 1st, or just x. So that tells me that what goes up here in this spot is 4x. Now let's try to do it with the other set of parentheses, or the other term in the parentheses. What goes right there? Now I know the next part of the distributive property is 9x cubed times whatever I put there should give me 45x cubed. So to figure out what goes there, I'm going to divide. Shelby's already putting the answer in chat. You're correct, Shelby. I'm going to go ahead and divide 45 divided by 9 is 5. X cubed divided by x cubed is 1, which means I do not need to write the x's. It's just 5 times 1, which is 5. So that goes right there. So I think that my answer is 9x cubed times 4x plus 5. I think that is my answer. If I've done everything correct, that is the answer. This is factoring, yes. If I've done everything right so far, that should be my answer. Is there a way that I could just give myself that extra boost of confidence to make absolutely sure that I've done this correctly? What could I do to check my answer? I have low confidence in my math skills and I got to get this question right or my mom's going to be so mad at me. And the answer is I can check my work by multiplying. Let's just check it. So 9x cubed times 4x is 36x to the 4th. And 9x cubed times 5 is 45x cubed. Is that what I was supposed to get? Well, let's go back up and check the problem. Yes, it was. The problem was 36x to the 4th, 45x cubed, which is what I got whenever I multiply these together to check my work. Okay. Okay. We're going to factor 12x to the 9th plus 5. Step number 1 on these problems, find the greatest common factor. Number 1, find GCF. Now I know the greatest common factor is not going to have an x in it. How do I know the greatest common factor will not have an x? That's exactly right, because the 5 does not have an x. If the 5 doesn't have an x and the 12 does, good for the 12, but that's not a greatest common factor because they don't have it in common. To be in common, they have to both have it. So my greatest common factor is not going to have a variable. My greatest common factor is just going to be a number. Awesome. So, okay, so you're saying 60, you're making a very common error here. You're doing a common multiple. I want a common factor. Multiple is what's something both of these numbers could be multiplied together to get. You use that whenever you find a common denominator with fractions. You can just multiply them together and get a common multiple. My question is, what's the common factor? What is the biggest number that both 12 and 5 can be divided by? So if I was doing this myself, I'd start with 5. What's the biggest number you can divide 5 by? The biggest thing that 5 can be divided by. 5. 5 is the biggest thing that 5 can be divided by. Can 12 also be divided by 5? 12 is even. Can 12 also be divided by 5? Even numbers can be divided by 5 sometimes. 20 can be divided by 5. The answer is no. 12 can't be divided by 5. Okay. So what's the second biggest number 5 can be divided by? 1. Can 12 be divided by 1? Yes. So the greatest common factor for this problem is 1. The second thing is the greatest common factor goes outside the parentheses. So I'll have the 1 outside my set of parentheses. Since there were 2 terms in the problem, 12x to the 9th and 5, there will also be 2 terms in the answer, in the parentheses of the answer. So I'm going to have 2 terms separated by a plus sign. Very good, Pedro. So step 3 is going to be divide the polynomial by the greatest common factor to find what goes in the parentheses. So my greatest common factor is 1. That's going to be really easy to divide by. What's 12x to the 9th divided by 1? Take your time. 12x to the 9th divided by 1 is... Oh, it's 12x to the 9th. Plus. And then what's 5 divided by 1? 5. There's my answer. Very good, Brock. The answer is 5. Easy peasy lemon squeezy? I think you only said that because peasy and squeezy rhyme with easy, because I don't think peasy is a word. And is squeezy a word? Even if squeezy is a word, lemon squeezy has nothing to do with something being easy. I don't understand this expression. It's like when people say winner, winner, chicken dinner. I mean, chicken dinners are fine, but I don't think I'd like scream and shout and write home about it. Guess what I won, Mom? Chicken for dinner. Seems like, I mean, I don't want to say it's a terrible prize because I like chicken, but people get way more excited about it than they should. They should say winner, winner, $1 billion, which doesn't rhyme, but is a much better prize than a chicken dinner. Or winner, winner, math lesson from Mr. Taylor, which is also fantastic. Some might say more valuable than $1 billion. Let's do one more of these. And this one's a little trickier because we don't have 2 terms in our problem anymore. We have 3. Oh, great question. Can we do this since there's a negative? Of course. We like negatives. We like minus signs. We can divide by a negative. Everything's cool. Calm down. It's going to be all right. Step number 1, find the greatest common factor. Now, finding the greatest common factor here is going to be a little trickier because we have 3 numbers. Now, I don't necessarily care that the 20 winner, winner can of paint thinner.
I like that one.
Beat them up, Mr. Taylor.
I don't care that the 20 is negative because negative 20 can be divided by everything that positive 20 can be divided by. So I don't care about the negative right now. I just care about the numbers. 16, 20, and 8. So those are all even numbers. So I know for sure that a common factor is 2, but is that the greatest common factor? So I'm going to start with 8. What's the biggest thing that 8 can be divided by? 8. Can 16 be divided by 8? Yes, it can. Can 20 be divided by 8? No, it cannot. So that's not a common factor because even though 8 and 16 can be divided by 8, 20 can't. So that one's out. The next biggest thing 8 can be divided by is 4. 8 divided by 4 works. Can 16 be divided by 4? Evenly divided by 4? Yes, it can. Can 20 be evenly divided by 4? Yes, it can. So 4 will be a part of the greatest common factor. Not 6, because none of those numbers can be divided by 6. So not a common factor, although 6 is pretty great. So 4. Now let's look at the variables. So C is the first variable we'll look at. Do all 3 of our terms have a C in them? No. So that won't be part of our greatest common factor because it's not in common. Next, we'll look at D. 16 has a D. 18 has a D. 20 does not. So D is also not in common. So it turns out the greatest common factor here is just 4. That means 4 is the thing that is outside the parentheses, because that is the greatest common factor. So 4 is outside the parentheses. I'm going to figure out what goes inside the parentheses, but first, how many things will be inside the parentheses? How many terms? Well, the problem has 1, 2, 3 terms. So my solution should have 1, 2, 3 terms. And I'm going to just carry the signs down. There's a minus sign and a plus sign. So minus, plus, just like that. Just like in the problem. And now to figure out what each one of those terms in the parentheses are, I just take each term from the problem. 16 c cubed d cubed. 20 c to the 4th. Notice I'm ignoring the minus sign here because I already put it in the problem. I already got the minus sign taken care of. And then 8d squared. And each one of those is going to get divided by my greatest common factor of 4. This is going to be pretty simple because I don't have to worry about variables here. I'm not dividing by a variable. I'm just dividing by a constant, 4. So none of the variables will change. So 16 c cubed d cubed is going to be something c cubed d cubed. 20 c to the 4th is going to be something c to the 4th, and this will be something d squared. The variables aren't going to change because I'm not dividing by a variable. I'm just dividing by a number. So that's the only part I have to do is divide by the number. Let's go back to our first term. What is 16 divided by 4? Oh. What's 20 divided by 4? 5. And 8 divided by 4? Dos. The sequel to the popular game Uno. So in parentheses, 4c cubed d cubed, 5c to the 4th, 2d squared. Or not 2d squared. Right, guys? And there's my solution. And that's the way, I like it. Yes, Pedro, may I help you? Oh. Thank you. Thank you. Now, this is not the only day we're going to spend on greatest common factor. We are just dipping our toes into greatest common factor. We're going to get a little more in depth with it next week. But for now, I just want you to focus on the basics, finding the greatest common factor, and then dividing your original problem by the greatest common factor to figure out what should remain in the parentheses. Does anyone have any questions about factoring with the greatest common factor? Does anybody have any questions just about life in general? Yes. How do you get a good life?
Graduate school.
Oh, when I find out, I'll let you know. Okay, go ahead, Pedro. The key to having a good life is to be satisfied with the way your life is right now.
If you aren't satisfied with the way you want to do
That's the part you should work on. Why am I so handsome? Well, I'm afraid I'm not able to answer questions based on a false premise. Yes, I will be happy to send you these notes. Anybody else have a question?
I forgot what mine was.
Okay. Good job, everybody, especially me.